Hello, today I will be discussing Lab 3, Magnetic Field of a Bar Magnet. The purpose of this lab is to obtain a better understanding of magnetic fields for a dipole. To understand this concept, we can use the distance dependency of the magnetic field to compare these values to predictions made by equations from the Biot-Savart law. From my calculations, I found that n is equal to negative 2.8955, k is equal to 6.911 times 10 to the negative 7, and mu is 3.456. From the computational results, I found that B net is 3.586 times 10 to the negative 5 teslas. The fundamental concepts and principles in this lab are modeling a bar magnet as a dipole and visualizing the magnetic field. The distance dependence on the magnetic field, which is found by the formula Kr to the nth power, linearization for modeling, which is important for graphing and data, and also the Biot-Savart laws. The initial conditions for this lab involve the phone with the magnetometer app placed on a ruler based on the setup depicted on the right, and the system is the bar magnet. Before beginning the experiment, I calibrated the setup to account for the Earth's magnetic field. Then, after identifying the location of my phone's magnetometer sensor, I was able to make measurements based on the location of the bar magnet. I did this 3 times for 5 different distances. As seen from my data, I chose 5 different locations where each corresponds to different x-component values of the magnetic field. After linearizing the data and plotting it, I found that my end value is negative 2.8955, which is the slope of the line, and my natural log of k value is negative 14.185. The next part of the experiment involves measuring the off-axis magnetic field. To do this, I changed my setup so I could use the distances off the axis. After finding the x, y, and z components of the net magnetic field, I corrected the y component and computed the magnitude of the net magnetic field. I observed that when the magnetometer is far away from the magnet, it measures a magnetic field value that is almost 0 in the x direction. Additionally, as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Here I have written out my calculations. From the line equation, I found that n is equal to the slope of the line, which is negative 2.8959. The natural log of k is equal to negative 14.185, and I found the value of k to be equal to 6.911 times 10 to the negative 7. I assumed that r is equal to 1, and I found an expression for mu by setting the Biot-Savart law equations equal to each other. After plugging in my known values, I found that mu is equal to 3.456 area times meter squared. Here's my GlowScript code. I created a function that calculates the magnetic field based on various locations on the axis and also perpendicular to the axis. I also have the 45 degrees off axis, which is based on the perpendicular distance that was measured in the second part of the experiment. Here's the GlowScript model itself. The blue and orange arrows represent the on-axis perpendicular and parallel magnetic field, and the pink arrow represents the 45-degree angle off-axis magnetic field. Here we can see how the values from the experimental calculations and computational model compare. From the experimental calculations, I calculated that the magnitude of the net magnetic field was 4.145 times 10 to the negative 5 on average. However, for the computational model, I found a lower value, which is 3.586 times 10 to the negative 5 teslas. The difference in these values could be due to systematic errors during the experiment. As for some discussion questions, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? My result would have been wrong due to the interference of Earth's magnetic field. This would have led to inaccurate results for both parts of the experiment. What if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The measurements from the experiment would have increased because the magnetic field would have combined and increased accordingly. Thank you for watching.